In this demonstration, we're going to have a look at how to use Data Services Manager to provision a data service, in this case, a PostgreSQL database, onto some vSphere infrastructure. Now, if you watched the previous video on this topic, you will have seen how to set up an infrastructure policy, which is essentially how a VI admin controls where the objects that back the data service, in this case VMs, where they are placed on vSphere infrastructure. So we will see then in this particular demonstration how during the creation of a data service, we will leverage that infrastructure policy so that the data service ends up on the appropriate vSphere infrastructure. Now, one of the things we saw in setting up the infrastructure policy is we also saw a section on how to set up permissions, and those permissions relate directly to how we can log on to the Data Services Manager UI. So I am going to take one of those permissions that we saw in the previous demo and log on to my Data Services Manager. And so we're landed here straight in the dashboard. The dashboard shows you information about permissions, shows you information about the databases. You can see that we have a number of databases already provisioned, but it also gives you details about the setup and the configuration of this particular appliance, what we call the Data Services Manager provider. So you can see a bunch of things like the repositories on the external storage have all been configured. We can see the TanzuNet token, which allows us to pull down information about later patches, latest releases, any updates that might be available for the products that we have deployed. We can see that we have LDAP configured, directly related to the permissions model as well. We have SMTP configured for sending email notifications to those people who might be interested in what's happening with the databases and data services. And indeed, we have log forwarding configured as well, where we send the logs from the provider appliance itself, as well as the data services to some log management system. In this case, it's been sent to the Log Insight product. Now, the purpose of this demonstration, as I said, is to show you how to build a new database. So let's go ahead with the Create Database. And I said we're going to build a Postgres database. So the first thing you need to do after selecting the engine is select which database version. You can see we support a number of different versions of PostgreSQL. I'll just select the latest one. We'll give it a name. In this particular case, I'll just call it demo. And you have now the option of deciding whether you want to have some replication associated with your PostgreSQL database. Now, by default, it's just standalone. So in other words, what we do is we provision a single VM or a single Kubernetes node, and on that node, we run the Postgres service. The other option, if you do want some sort of availability and replication, you can select this option here for multi-nodes, and then the topology below allows you to select either 3 or 5 nodes for the PostgreSQL cluster. You can see here the 3 nodes. It's a primary, a single replica, and then the monitor component is put on its own separate VM or node. But in the case of 3 replicas here, the 5-node topology, single primary, 3 replicas, and the monitor is once again on its own node. We'll just go for the 3-node in this particular case. Now, the database name itself assumes the same name as the instance, but you can, of course, change that if you so wish. And the final thing to note about this basic information is the admin username. So we're creating a user that will give you access. You'll see shortly that you can copy a connection string that will become available once the database has been instantiated, and we will use this pgadmin username to access the database. So that's the basic information. Now we come to the section which relates directly back to the infrastructure policy that we built in the previous video. You can see we have a number of different infrastructure policies. I'm just going to pick this one here, InfraPol 1. You can select placement. So if you had multiple compute resources within the same infrastructure policy, you can choose to select placement. And you can see here that I had 2 clusters, A and B, so I can select either one of those. But I could also just let DSM choose where to place it. Now, from an infrastructure policy perspective, we also had a storage policy added to it. We only added a single storage policy, which is why only one of them is showing there. So not much to do with that, but you could have multiple storage policies in the infrastructure policy as well for placement. Similarly for VM class, there's only been a single VM class added to the infrastructure policy, but if you had multiple VM classes added, this is where you would make your selection. And last but not least, the size of the disks that are associated with the nodes that we're provisioning for the database. Maybe 60 gig is not enough. You might want to bump that up to something like 120, whatever the case may be. And that is the infrastructure selected now for the placement of the data service. We now get into some database specific stuff, such as backups. Backups are enabled by default, and one of the configuration items that needed to be configured at setup time was to select a backup location for databases. And that's defined there. It's actually an S3 bucket. And the final thing here to do with backups is the retention period, and it's 30 days. So we'll keep the backups available for 30 days before rotating. The backup schedule itself, we're using a default backup schedule. For PostgreSQL, that's weekly full backups, incremental daily, and of course we write the write-ahead logs, the wall logs, every 5 minutes out to the backup location as well. And that's what allows us to do those point-in-time restores. The final thing here is the maintenance window. So look at that. Maintenance window is all to do with updates and patches and new versions of the PostgreSQL database. If the maintenance window is enabled, that means that we will automatically apply those updates for you. Those minor versions of the PostgreSQL database will be applied automatically, and they will be applied on Saturday night at a minute to midnight, so Sunday morning essentially. You can, of course, disable that, and that would mean that as new updates become available, you would have to manually apply those to your databases. But this allows us to apply patching across your whole fleet of databases automatically if you so wish. And then we get to the final section of the creation of the database. This is the database options. You don't need to do anything here if you don't want to, but a lot of our customers have mentioned that they like to tune the database with their own specific advanced options, advanced parameters. So you can add these advanced parameters here. Just by way of example, let's do something like max connections. By default, it's 100, but maybe you expect to have a lot more connections to this particular database, so you can bump that value up to 150. And what that does is it creates a config file that gets attached to the database, and those advanced parameters that you add here will get applied to the database at creation time. So you can just review all of that information now. And if everything looks good, you can go ahead and hit the Create Database button. And now you can see that the database that we call demo is in progress. And what we'll do is we will pause recording here. And then once we get to a ready state, we'll come back and review what has just taken place. Okay, and our demo PostgreSQL database version 15.5 with 3 nodes is now ready and doesn't have any alerts. And also the storage size that we gave it, 120 gig, that looks good as well. Let's check a few more details. And here in the summary page, you can see the details about the connection string that I alluded to earlier, which will connect you to the database as a PG admin. Can be copied from there. Some labels associated with the database, including the infrastructure policy and the VM class. The replication that we selected, remember we asked for 3 nodes or a topology of 3 nodes with a single primary, a single replica, and a separated monitor. You can see all of those in their different VMs and their various roles there as well. Keep going down, more details about the infrastructure policy, including the storage policy and the disk size. Our maintenance window for minor version upgrades is there, and we don't have any available upgrades at this point in time. And last but not least, if we look at our database options, we can see the max connections at 150, which is what we requested. The other thing that would be interesting to look at, I suppose, is monitoring. There's very little in the way of stats coming through just yet, but they will start to fill in as the the database is online for a little bit longer. Backups, so you can see I mentioned the schedule. We have a full backup every week, every Saturday. We have daily, again just before midnight, and we're shipping the write ahead logs every 5 minutes. All looks good. If you need to get a log bundle, you can do that here. Just generate a log bundle. It'll shortly become available for download. And then the various operations that are run against this database can be monitored from that tab. So at this point in time, I think we can complete the demonstration, and hopefully that's given you a good idea of how simple it is to create a PostgreSQL database through Data Services Manager and selecting the appropriate vSphere resources through the use of infrastructure policies. Thank you for watching.